Lesson 27. This lesson we're going to talk about multiples, least common multiples, and equivalent division problems. We're going to find the common multiples of two or more numbers. We will find the least common multiple of two or more numbers by listing their multiples and then by using prime factorization, both methods. We're going to form equivalent division problems and mentally calculate their quotients. Our vocabulary. The least common multiple. That's the smallest multiple that will go into two numbers. A multiple being a number. A multiple is all the numbers that are created by multiplying a number by 1, 2, 3, 4, 5, and so on. So, when we talk about the multiples of a number that are produced by multiplying numbers by 1, by 2, by 3, and by 4, and so on. So, the multiples of 4, the number 4, if we multiply 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 4, 4 times 5 is 20. Those are all multiples of 4. If we did the same thing for the number 6, this is the set of numbers we would get. Then you'll notice that I've highlighted in yellow those multiples that are the same. Those are the same multiples. So if the question was asking for the least common multiple of the number 4 and 6, you would select 12. If we inspect the two lists, we see that some number in both lists are the same. The numbers appearing in both of these lists are called common multiples of 4 and 6. So if we are told to find the least common multiples of 6 and 8, we'll do the same thing as we did on the prior one where we knew that 12 was our least common multiple because we found them. So let's start with 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. I don't know if we need to do any more. Let's do the 8 now. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. So we can now see that our very first common multiple is our least common multiple of 24. So see if you can do it for 3, 4, and 6. Pause the video, do it, see if you can come up with the least common multiple of 3, 4, and 6. All right, let's start with 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Let's just stop there. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And then 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. So what multiples do we have in common? Well, they all have a 12. They would eventually all have a 24 also, but we're looking for our least common multiple, which we know to be 12. On this one here, 18 and 24, we don't want to do it the way we've been doing it because those become very large numbers. 18 times 1 is 18. 18 times 2 is 36. 18 times 3 is, I'm not sure. 18 times 4, I don't even have a clue. 18 times 5, 90. Right? That would be really, really hard. And it'd be even harder with 24. So when we do 18 and 24, we're going to use prime factorization. So let's do that together. So we start with 8, and because we're doing prime factorization, we're going to do a tree, right? A 2 and a 9 and a 3 and a 3. So I know that 18 is 2 times 3 times 3. Now, for 24, do the same thing. Start with the smallest number that can go into it, 2 and 12, 3 and 4, and then 2 and 2. So 24 is going to equal 2 times 2 times 2 times 3. Okay, now to find the least common multiple, and this is the tricky part, you need to really pay attention right here for this step. Both of these numbers have 2's and 3's. Which one has the most 2's? The 24 does. So we're going to take out all of these 2's and put them over here. 2 times 2 times 2. Which one has the most 3's? It's the 18, and it has 2 of them. So we're going to add over here 2 times 3 times 3. Now, to get the least common multiple of 18 and 24, we times these together. 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. Our answer for this is going to be 72. I know that was confusing, so watch it again. Back up the video and watch it again. Let me show you how these show it. They come up with they factored it just like we did, and then they did the same thing. Here's their 2's, they pulled those out right there, and here's the one with the most 3's, and they pull that right there, and they multiplied those all together, and they got 72. That's very different from the way we calculate the greatest common factor, because we're not looking for factors here, we're looking for multiples, common multiples. So let's practice a little bit. I know we need to do this. 8 and 10. Okay, we could do 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is, I don't know. So let's factor it instead. I think that would be easier, don't you? Okay, so it's 2 and 4 and 2 and 2. So we know 8 is going to be 2 times 2 times 2. 10 is going to be 2 and 5. So now they both have 2's, so which one has the most? The 8 does. So we're going to take all of these 2's. So we're going to go 2 times 2 times 2. 8 doesn't even have a 5, so we know that the 10 has the most 5's, times 5. So 5 times 2 is 10, times 2 is 20, times 2 is 40. So our greatest common factor, or greatest common multiple, I'm sorry, of 8 and 10 is the number 40. Now for 4, 6, and 10, you do it. See if you can do it. I'm sure you can. Okay? 4, you could do it either way. You could lay them all out. You know, this one here is a little bit easier because it's smaller numbers. So you could go 4 times 4 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and you could just keep on going up. But I promise you, you're going to have to do some really big numbers. So you do not want to do it this way here. You do not want to do it that way. You want to do factorization. So start with our 4. 4 is going to be 2 times 2. We know that. Our 6 is going to be 2 times 3. Our 10 is going to be 2 times 5. So let's start pulling them out. Which one has the most 2's? The 4 does. So we're going to pull out 2 2's. 2 times 2. Which one has the most 3's? 6 is the only one with the 3, times 3. 10 is the only one with the 5, times 5. So now we're going to multiply those together. 5 times 3 is 15, times 2 is 30, times 2 is 60. So our greatest common multiple of 4, 6, and 10 is the number 60. So you can imagine if we'd kept going here, 20, how long our list would have had to be before we got to 60, right? So we use prime factorization to help us find it. It's much faster, a lot easier. We also can use equivalent numbers to help us find answers quite quickly. If I said to you, what's 220 divided by 5? That's hard. You can kind of do it in your head. You could do it like this, 220 divided by 5. You can do it that way there. Or you could do equivalent numbers. Can't we times, isn't 10 an easy number to divide into a large number? So let's take our 5 here. and times it by 2. That becomes 10. And let's double this one here, times it by 2, and that equals 440. Take out our 1s. What's our answer? 44. How fast was that? Slam, bam, snap. That was easy. 5 goes into 220 44 times. Just by doing equivalence. Taking and making it easier. Knowing that if we double everything, make that 5 a 10, then our math can become much, much easier. Refer to this circle with a center point at point M to answer A through E. I want you to see if you can do these, and then here are your TIDs for tomorrow. You need to be sure and do those and turn them in. But I want you to practice these. Which chord is a diameter? Which one of those chords is a diameter? That's going to be CB. It's this chord right here. Diameter goes all the way across, or BC. Which chord is not a diameter? It would be this chord here, right? It's going to be AB or BA, because MA, that's a chord, that's a radius. But this definitely is not a diameter. Which angle is an acute central angle? Let me get that drawing off there for you. Which is an acute central angle? That will be AMC or CMA. AMC or CMA. This is acute central angle. And which angles are inscribed angles that are found inside of the circle? You've got ABC, that big one right, that gigantic one right there, and you also have this one here, AMB or BMA. Those are both inscribed inside of the circle. The other one was like this. And then which two sides of the triangle A and B are equal lengths? Which two sides of the triangle A and B are equal lengths? Which two sides are the same length? Well, we know it's going to be AM and BM, or MB, and the reason why is because these are both from the center point. All right, hopefully you're able to recall that from lessons before. Please do problem 5A and B, 7, 9A, B, and 7 to me. If you have questions, save them. Let's talk about them in class tomorrow.